Hey guys, it's Miss Johnson, and I'm here to bring you the second piece of designing experiments. We're still in section 4.2. This is actually the third part of our 4.2 lesson, but today we're going to wrap up our designing experiments discussion. So we've got a few more terms today and a little bit more discussion about how we design a successful experiment. Here are those 2 pages of learning targets because section 4.2 has quite a bit of terms and definitions and a lot to it. So we have 2 pages of learning targets here. All right, so we talked a little bit in the first part about control, but let's just go into control a little bit more. So it says in an experiment, control means that you keep every other variable constant for all experimental units. So the more controlled you can be, the more accurate your results will be. So it says after randomly assigning treatments and controlling other variables, treatment groups should be about the same except for the treatments. Then a difference in the average response must be due to either the treatments themselves or to the random assignment. We can't say that any difference in average response between the treatments groups must be caused by the treatments because there would likely be some difference just because random assignment is unlikely to produce exactly equivalent groups. Even though we randomly assign the subjects to the treatment, it's unlikely that your groups will be exactly equivalent. Especially when you're talking about people, even when you're doing this with animals. Animals are all different. People are all different. It's not possible to have perfectly equivalent groups. But that just goes back to the fact that in this land of statistics, we kind of permanently live in the gray area. It's not completely black and white. It's not going to be completely perfect. There's no such thing as a completely perfect experiment. There's no such thing as a completely controlled experiment, especially when you're working with people, because every unique individual is so different. It's impossible to make your groups exactly equivalent, okay? That goes into the fact of saying association cannot imply causation. There's a lot more that we have to do in order to imply causation, and there's some testing that's involved that we get into later in this year. Another thing that's important in designing experiments is replication. So in an experiment, replication just means that we're going to use enough experimental units for it to be statistically significant. If we don't have enough subjects in the experiment, then the data that we collect is not going to be reliable enough. So you need to use enough experimental units in your experiment to make the data reliable, and that's your replication. Replication is using enough experiments. Replication in this case means something a little bit different than what it means traditionally in the English language, but just in this case, replication means that we're using enough subjects. All right, so here is just kind of all 4 of those pieces together. Some of the parts that we talked about yesterday and some of the parts that we talked about today. Comparison is when we use a design that compares 2 or more treatments. A comparison experiment is by far the most common form of an experiment, is when we're just assigning treatments to randomly selected groups and comparing the results of those treatments. So that's the most common form of an experiment that we'll use. Random assignment is key. You have to have random assignment. If you don't randomly assign your subjects, then your experiment data is not valid. So using chance to assign experimental units to treatments, doing so helps create a roughly equivalent groups, which is really important when trying to measure the effects of the treatments. Then control is making sure that you keep all other variables the same. You treat your experimental units the same. You try to control all other variables, meaning like you're going to pull pull experimental units that are closely related to each other. They have things in common. They have common characteristics. You do your best to control as much as you can. You control their environment. Sometimes that means controlling their environment, depending on what you're testing. And then replication just means that you use enough experimental units so that any difference in the effects of the treatment can be distinguished from the chance difference between the groups. So here's just kind of a nice visual of what that experiment looks like. We randomly, and then remember that getting to even this piece of randomly selecting the experimental units is a task. You have to make sure that your randomly selected experimental units were chosen in an appropriate way without introducing bias. We talked about non-response bias, and we talked about convenience sampling, and we talked about, all those different kinds of sampling where there could be some bias that is introduced if you're not careful. So getting to this piece where you have your experimental units is the first battle. That in itself is a big thing. Then once you have your experimental units, you hop over here to the random assignment piece. When you randomly assign your subjects to group 1 and group 2, or group A and group B, sometimes there's more than 2 treatments. This is just the most basic experiment would be 2 groups. You have treatment 1, you have treatment 2. Hopefully, ideally, you want these things to be double blind. You want double blindness right here and right here. And then you collect the data and you compare the response. So you look at the data that you are trying to check and you compare what the responses are and you go from there. All right, so that's the very, very basic experimental design. We're going to get into some more theories behind experimental design and what can go wrong with experimental design later in this chapter. But thanks for listening for today, and I will catch you next time.